Yep, that was pretty neat. Welcome to another Hopper on the Raspberry Pi Pico video. Hopper is a modern semicolon and curly brace language, similar to Java or C Sharp, but without classes and designed to run on small platforms. For example, it runs on the Raspberry Pi Pico, and it runs on platforms like the 6502 CPU. What we just saw there was the Barnsley Fern on displays that are that I've been working on writing drivers for Hopper for the Raspberry Pi Pico. If you're interested, if you look on Wikipedia, you can read about this fractal, named after the British mathematician who first brought attention to it when he published a book in the late 80s that included this example. It's a surprisingly simple algorithm to come up with a self-repeating pattern that ends up looking so pretty. Anyway, I've used this example. It's an example of floating points on a floating point in Hopper. And it is also, I use it to work on performance floating point, but it also makes a good demonstration of the fact that of how you configure displays with my new display drivers. So I've got two displays hooked up to this device right now. On the right is this 2.8 inch TFT LCD, and in front we've got this OLED display here, little 128 by 64 OLED display on this Raspberry Pi Pico. So in Hopper you can only talk to one display at a time, so first the one and then the other, and then in those methods I configure the first display, I draw the Fern to it, and then I call end, and then in the other one I configure the display, I draw the Fern, and I call end. If we go and look at how the configured the display looks, let's have a look at that. So if you go to the Getting Started playlist on YouTube for my channel, you'll find out how to get this this development environment working on Windows, and also how to get Hopper onto your Raspberry Pi Pico. Once you've done that, you don't have to change what's on your Raspberry Pi Pico to support these kinds of devices. You just change your Hopper code and just upload it. So it chooses the device driver for the display and the resolution. For SPI interfaces, it needs to choose some pins. And for the I2C interfaces, it just needs to choose an address. Far preferable, much simpler, because this will be the same for all devices, not just the Pi Pico, whereas these pins are specific to how you've wired it on your Pi Pico, and you could do that differently. Anyhow, and then it calls begin. So I mentioned the end at the end. This starts a session for a display. If your session is infinite, you never need to call end, and when the system wraps up, it'll call end by itself. But if you're going to switch to another device, another display, then you need to call end before you configure the next device. Right. Yeah, I think that's enough about displays. So we have displays working on the Pi Pico, and you've learned about, if you didn't know before, about how these fractals are drawn. So I will end by launching this in the debugger again, and I'll start the process again, and it'll first draw the one and then the other. So first it's going to draw the color one, and then it's going to clear the monochrome screen and draw the mono one. So this is really the end of the video, so you could cut it off here, but I'm going to play it out. So let's go. It clears the screen, starts drawing dots. It's going to take about a minute. Anyway, thank you for watching. Let me know if you have any issues trying to get Hopper running on your Raspberry Pi Pico. I look forward to your feedback.